This video is about solving equations with variables on both sides. The first step is going to be to simplify, distribute if necessary, and then move variables to one side of the equal sign, and finally solve for the variable. Please press pause right now and write down what you see on the screen, including these two examples, and then we'll take a look at how to solve these examples. In the first example, we can see that each side of the equal sign is already simplified and there's no need to distribute. We have 6x plus 3 equals equals 8x minus 21. Now what we need to do is move variables to one side of the equal sign. I recommend that the variable that you undo, so to speak, is the one that has the lowest coefficient. Here we have 6x, here we have 8x. 6 is less than 8, so let's subtract 6x from each side. The 6x minus the 6x, that becomes 0, so just rewrite 3. 8x minus 6x is 2x minus 21. Now solve this problem like you have before. Add 21 to each side, and you get 24 is equal to 2x, and divide each side by 2, and you find that x is equal to 12. In the next example, we have 3x plus 1 equals negative 5x minus 7. There's no need to distribute, and the left side and the right side are both simplified. Now it's time to move variables to one side of the equal sign. Well, notice here we have 3x, and over here we have negative 5x. Negative 5 is less than positive 3. So we are going to do the opposite of negative 5. The opposite of subtracting 5 is adding 5. So we're going to add 5x here. And then we're going to go to the other side of the equal sign and add 5x. We then have 3x plus 5x is 8x plus 1 equals negative 7. Now subtract 1 from each side, and 8x equals negative 8. Divide each side by 8, and x is equal to negative 1. Please take a look at these two examples, press pause and copy these down into your notes, and then we will solve them. In the first example, we have 2 times the quantity c minus 6 is equal to 7x plus 2 plus 2c. I'm sorry, that was 7c plus 2 plus 2c. First, we have to distribute. 2 times the quantity c minus 6 is 2c minus 12 equals, here we have to simplify by combining like terms. 7c plus 2c is 9c, then plus 2. Now each side of the equal sign is simplified, and we need to look for the term that has c in the lowest coefficient. Well, here we have 9 and here we have 2, so we're going to do the opposite of adding 2c. We're going to subtract 2c because 2 is smaller than 9. That leaves us with negative 12 here. On the right side of the equal sign, 9c minus 2c is 7c. And then plus 2. Okay, now we're going to subtract 2 from each side. And we have negative 14 is equal to 7c. Divide each side by 7. And we have negative 2 equals C. In the next example, we have some fractions. We're just going to recopy the 1/2 times d plus 2. And now we're going to distribute. Negative 1/4 times d is negative 1/4 d. Next, negative 1/4 times negative 3 is positive 3/4. The reason for that, I'll just write over here on the side, 1/4 times 3 is like saying 1/4 times 3 over 1, which is, of course, is 3/4. Okay, now look at your fractions and look at your denominators. Here we have a denominator of 2. Here is a 4, and here's another 4. In order to get rid of the fractions, we want to multiply all the terms by the lowest common multiple of these denominators. And if you think about 2 and 4, the lowest common multiple of 2 and 4 is 4. Both 2 and 4 go into 4. So since 4 is the lowest common multiple, we're going to multiply every term by 4. So put parentheses around 1/2 d, multiply that by 4. Put parentheses around the 2, we're going to multiply that by 4. Put parentheses around the negative 1/4 d, we're going to multiply that by 4. And put parentheses around the 3/4 and multiply that by 4. Okay, 4 times 1/2 is 2. If you want to, you could think of it as 4 times 1 is 4, and then divide by 2. It's 2. So we're just going to write 2d. Next, we have 4 times 2. Of course, that is 8. Four times negative 1/4 is negative 1. So we're just going to write negative d. You could think of this as 4 divided by a negative 4 if you want to. Of course, 4 divided by negative 4 is negative 1. And then here, 4 times 3/4, that's 3. Here's one way to think about it. 4 goes into itself once here and again here. So we have 3. Now there are no more fractions. It's 2d plus 8 equals negative d plus 3. Negative 1 is lower than 2. So we're going to undo this right here by adding d to each side. And this becomes 3d plus 8 equals 3. Subtract 8 from each side, and we have 3d is equal to negative 5. Divide each side by 3, and we have that d is equal to the fraction negative 5/3. And it's fine to leave that as an improper fraction, negative 5/3. You could also write it as a mixed number, negative 1 2/3. Please press pause and copy down these 2 final examples. In the first example, we have 10 minus 8a is equal to 2 times the quantity 5 minus 4a. Let's rewrite 10 minus 8a. And now we need to distribute. 2 times 5 is 10. Minus 2 times 4a is 8a. Now notice we have 8a, actually negative 8a or minus 8a here, and also over here on each side of the equal sign. So let's just pick one of them. We'll pick the one on the left here, and we'll do the opposite. We will add 8a here and add 8a here. And when you do this, you have 10, and of course negative 8a plus 8a is 0, equals, and we have 10, and then we have negative 8a plus 8a is 0. So we end up with 10 is equal to 10. Whenever you see a situation like this, where at the end of your problem you have some constant equal itself, such as 10 equals 10, or 3 equals 3, or negative 5 equals negative 5, this is a special situation that tells you there's actually an infinite number of solutions to this problem. In fact, there's not just one answer. In the previous problems today, there was just one answer to each equation. But here, you could say that all real numbers will work to solve this equation. You could put in place of a, for example, 2. If you put the a equal to 2 here and here, this equation would work out to be true. But 2 is not the only solution. I'm just randomly picking numbers. I could put in negative 56 for a and substitute that in, and again the equation would turn out to be true. All real numbers will work in place of a. Another way to describe this type of problem is that there is an infinite number of solutions. Not only could you put integers in here for a, you could put in fractions, you could put in decimals. So all real numbers will work. There's an infinite number of solutions to this problem. Let's take a look at a problem where there's no solution. In this final example, we have 6m minus 5 equals 7m plus 7 minus m. Let's rewrite 6m minus 5. And next we need to combine like terms. 7m minus m is 6m plus 7. And we have 6m here and 6m here. Let's subtract 6m from each side. Here we have minus 5 or negative 5 equals, and here we have 7. Negative 5 equals 7. When you have a situation like this one, where you solve this problem and you end up with a statement that's not true, such as negative 5 equals 7, then that means that there is actually no solution to this problem. You've tried to solve it, but it isn't actually solved because it's not possible. So you write no solution. What this means is it does not matter what number you put here and substitute in place of m, you will never be able to find a number to substitute in for m that will make this statement true. Therefore, you simply write there is no solution to this problem. And now you have seen in this video how to solve equations with variables on both sides. You've seen examples where there is one answer to each problem, and you've also seen an example where all real numbers will work, and there's an infinite number of solutions, and an example where there's no solution.